All right, so today what we're going to do is we're going to look at some applications using the trig functions to find the sides or missing sides of triangles. So these are still going to be right triangles. They're just going to be given to you in a paragraph form or using a picture or something like that instead of just giving you just a straight picture with numbers on it that you have to find the values for. So let's just go to the book and look at some of these. They're pretty straightforward. Classic example is the ladder question. So if you look here, it says a ladder is leaning against a wall. If it makes an angle of 62 degrees with the ground, but pay close attention when you're reading these because you may have one where it's just the paragraph and you have to make the drawing. Okay, so be very careful when you're reading these because they'll give you clues about what to do on the others. Okay, so this angle is 62 degrees. Okay, and it reaches 2.5 meters up the wall. So they've got the measurement on the outside, but it's got to be the same measurement on the inside as well, right? So you can just extend that knowledge a little bit and then create a right triangle out of those, because if it's meeting the wall, we assume that that's going to be a right angle. So we have our angle here, we have our x here, and we have our 2.5 here. So that is straight across, so in other words, that's the opposite. This one is right next to the angle, so that means that's the adjacent. And if you look at your SOHCAHTOA, the only one that uses opposite and adjacent is TOA. So we're looking for the tangent of our angle, which is 62 degrees. And that's equal to opposite, which is 2.5, over the adjacent, which is our x. And then it's just a matter of solving that algebraic equation. So we'll multiply both sides by x to eliminate the fraction. Gives us x times the tangent of 62 equals 2.5. Then we need to get the x by itself. And since it's connected to the tangent with multiplication, we'll take it apart with division. And of course, you guys are going to have to help me out here with the calculator business. Gives me x is equal to what is 2.5 divided by the tangent of 62. Someone, please.
1.33 rounded.
Okay, so 1.33, and then it repeats, or just 1.3?
Yeah, just 1.3.
Okay, all right, and of course, meters. There you go. And that makes sense because this one looks longer than this one, so 1.3 meters looks about right to me, yeah? Okay. So you're going to be using the same skills, you're just going to be given a scenario instead of just a picture of a triangle. Now, there will be a couple where you may have to go back and think about the Pythagorean formula as well. For example, okay, here we go. So if you look at this one in particular, it says, in order for the shed to shed snow, the pitch of the roof must be at least 22.6 degrees. If the roof must be 6 meters wide, so wide, then calculate its minimum height, in other words, the height here. So at first, this is just plain trig. We know our angle. We have this side, which is right next to it, so the adjacent. We have this side, which is straight across from it, so the opposite. So that's a simple tangent problem. So the tangent of 22.6 is equal to our opposite, which we don't know, let's call it h, over our adjacent, which is 6. We'll just multiply both of these by 6. So that gives me 6 times the tangent of 22 degrees, and it equals h. So h is equal to, can someone multiply 6 times the tangent of 22.6 for me, please?
2.4. 2.5.
2.5? Okay, works for me. And of course, those are being measured in meters. All right, so our height is 2.5 meters. Now, at this stage, we have to finish the question though. It says, how long will the roof be? Well, this is the part that the roof, where's the roof? We've just found the height. So we haven't answered the question yet. We've done the math we need to start it, but we still have to finish it. And there are two ways you could finish this. We still know this angle, right? And that's the hypotenuse. So I could use trig. I could do the angle, and then I'm looking for the hypotenuse, and I have the opposite. So that's a SO problem, right? Sine of 22.6 equals blah, blah, blah. Or, because we now know two sides, and we're looking for the third side, we can just use the Pythagorean formula. So, remember that these are the sides, right? And that's the hypotenuse. So it'd be 2.5 quantity squared plus 6 quantity squared equals C squared or roof squared. Who cares what letter you use? Nobody cares. And then 2.5 squared plus 6 squared, and then take the square root of both sides to get the answer. So don't forget that you have this tool. If you're looking for sides and you have two lengths, you don't have to go to the trig. Whichever one makes the most sense to you, but make sure that you're really careful and that you're answering the question that's being asked. Okay, so either one of those processes would get you the same answer. This one is probably going to be a few decimal places off, but so will this one be because you're going to take the square root of a decimal, so it doesn't really matter. And we'll think of both of those when we're grading the internal. We will think of both cases, both scenarios, so that you're not counted wrong if you have a slight rounding error because you used one instead of the other. Okay, so be very careful when you're reading these to think about the information they give you and think about the information that the question you're actually answering. Just look at this one. This one is a good one because they give you some information about eye level. So this 1.52 meters doesn't figure into finding this height. Okay. Now this length does. It's still 11 meters here, right? So if you're looking for this height here, that's an opposite and adjacent situation. I keep finding tangent ones. I'm sorry, that's a cotangent. So so that's no, it's not. That's an opposite, isn't it? I just put H for height. I'm so goofy. So that's still a TOA. So, but once you find that, then we have to think about this part of the tree is added into that. So once you find this bit of the height, then you just add that part in to find the rest. Okay? So be careful whether it's eye level or if there's other pieces you'd have to add or subtract. Now, I'm going to give you that one. You can work on that one. It's pretty interesting. All right? So, what I want you to do is I want you to work these through and find the answers to these. So we're just going to be doing page, let's see, what is it, 32? Page 32, and do 1 through 6. Pay close attention to that last one. You're going to have to do it in parts. Okay? So what we're doing is exactly the same information, but doing some applications involving those. Okay, so be really careful about what question is being asked. Let's come back to you guys.
Mr. Phil,
Yes. What's up, Catherine?
where is this book? Do we have it? I don't have one with me, but I assume that no one else has one.
Yeah, sir. So
Are they
yeah, I gave you the book
I do.
before we left, or I may not have given you the book before we left, but it's no big
I do
deal.
have mine.
Pardon?
I may have mine. I just completely forgotten.
There's one on OneNote.
But yeah, that's what I was going to say, Catherine. I put it on the OneNote. Let me just share my screen and show you exactly where you can find it. So if you just go to OneNote and the OneNote for our class, you'll see right-angled triangles there in the content library, and there's the Walker book. It's the only thing that I've posted there, is the 1.7 right-angled triangles.
Okay, great.
Okay?
Also, is this going to be an internal or an external?
This one is
And is it an internal